Here's a video on lesson 73. Since a lot of people were asked today, if you have any issues with this, you should attend office hours, but I'll go over it to the best of my ability here in this video. Now we have some notes to go through first. What is an inverse? What does the graph of an inverse function look like? And how do you find the inverse of any function? And then we'll go through two examples. Okay, I want to do the examples in full. So, what are inverse functions? Well, inverse functions undo each other. Inverse functions cancel each other out. They look like a reflection over the line y equals x, and in order to solve for the inverse of a function, you switch x and y, and then solve for y equals. If you want to write any of this down, just pause, because I'm going to move quickly. There's a lot to cover. Now, in order to find the inverse of a log, you absolutely are going to have to switch x and y, because we're looking for an inverse, and that's always the case. So if the question says find the inverse, it means you're switching x and y, and then you're solving for y equals. This solving for y equals part can be a little different every time. So for an inverse of a logarithm, solving for y equals looks like this: isolating the log term, and then swooping to convert it to exponential. So let's get started. For the example for number 4, I need to switch x and y. Well, x equals log base 2 of y minus 7. That was my step, switch x and y. Now that I've switched x and y, I need to isolate the log term. So I'm going to have to add 7 to both sides to get rid of that plus 7. Bye-bye to that plus 7. So now I get x plus 7 equals log base 2 of y. I don't really like the log on the right. I like the log to be on the left. So here's what I'm going to do. I'm going to rewrite this. In my case, I can be cheap and use the tools. For you, you might have to erase, or you might just want to rewrite it and cross it out on the left. But I like to have the log on the left. Once the log is on the left, it becomes easy to do this, the swoop. What the swoop does is it's telling me that 2 raised to the x plus 7 power equals y. In that order. 2 raised to the x plus 7 equals y. That's how the swoop allows us to change from a log form to an exponential form. And my goal, don't forget, is to find the function. What does a function look like? A function looks like y equals something. Okay? So we're done. That was it. Pretty painless. Now for the next part. In order to find the inverse of an exponential, it's going to be the same first step, switch x and y. This is going to be a little bit more involved. So let's switch x and y first, because the question asks for an inverse, and that's always what we do. So x is equal to negative 4 to the y divided by 3. Now I want to get y by itself, so I need to isolate the exponential term, which is this. So here's what I'm going to do. To get rid of the divided by 3, I have to times by 3. Times 3 times 3. Those cross out. On the left I get 3x is equal to negative 4 to the y power. I still need to get rid of the negative sign though, so what I'm going to do is I'm going to divide by negative 1 on both sides. It's an easy way to get rid of a negative. And the left side now becomes negative 3x is equal to 4 to the y power. Now in order to bring that y down so I can solve for it, I'm going to have to log both sides. Once it's logged, I can bring down the y. what I have now is I have log of negative 3x is equal to y times log of 4. In what is hopefully my last step, I get y by itself by dividing both sides by log of 4. These cross out. And I'm just going to rewrite because this is my final answer and I want to make sure that I keep it neat. Y is equal to log of negative 3x over log of 4. Now that's essentially what we've been doing, so it seems a little more complex because we have to switch x and y in the beginning, but besides that, it's essentially the same steps that we've been doing. Now the one thing that you did not know until this lesson is I can take these two logs, a log divided by a log, and I can change these to sort of smush them into one log. The way that that works is following a rule that looks like this. If I have the log of A over the log of B, this is equal to the log base B of A. So the top stays on top and the bottom becomes the base. And that's one way that I can smush two logs together. So when I apply that up top, up here, I can say that the log base 4, right, bottom stays bottom, of negative 3x, top goes on top. And that would be a 4 to 4 full credit answer. Okay. So those two are the examples that'll really help you out with the homework. There's one other thing that I really need to cover though, and then I'll do one of the homework questions to make sure there are no issues. What I do need to cover is the concept of graphing an inverse. How do you graph the inverse of a function? Now this was just classwork. What we do is we switch x and y on all points. Thankfully I don't need to find all the points, I'll just find some of them. What I'll do is I will graph the first one. That's the one that we did in class, so I'll do that one. What I need to do is I need to find the points on this graph, and then I need to switch their x and their y values. So this point right here is negative 1, negative 2, negative 3, negative 4, negative 5, and up 1. So this point is negative 5, comma 1. I'll find some other points that cross at nice even places. They're not hard to find on this function. This point right here is going to be negative 2, 1, 2, 3, 4. And let's pick one like up here. This is going to be 2, 1, 2, 3, 4, 5, 6, 7, 8. So this point is 2, 8. On the left side of the vertex down here, I'll pick this point, which is negative 7, 3. And I'll pick this one up here, which is negative 9, comma 5. Now that I have all these points, I literally just want to switch their x and their y values. So for this one, negative 9, 5, I get 5, negative 9. For negative 7, 3, I get 3, negative 7. For negative 5, 1, 1, negative 5. For negative 2, 4, I get 4, negative 2. And for 2, 8, I get 8, 2. Now I want to graph these points. 5, negative 9, 1, 2, 3, 4, 5, down 9. Just zoom out a little bit. 5, negative 9 is here. 3, negative 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 1, 5, 1, negative 5. So that's here. 4, negative 2. It's 1, 2, 3, 4, 1, 2, and 8, 2. So count over 8 and up 2. Now if I draw a straight line through these, if you use the edge of a binder or edge of a folder, if you have a ruler handy, you draw a line through these, you'll see that this is the graph of the inverse function. So if this up here we would call f of x, that's a function of x, this down here would be f prime of x, and that's the function inverse. Now I said earlier that this was a reflection over the line y equals x. If you know what the line y equals x is, it has a slope of 1 and it goes through the origin. This is that line. Isn't it obvious that this up here is flipped? This up here is just flipped over the line y equals x, and it becomes the red function, its inverse. Flip it over. Okay, so that's how you can graph the inverse of a function without actually knowing its equation at all. Very convenient. Now I'll give you a hint on the homework. Just a hint on 16 and 17. 16, what you're going to want to do is you're going to want to set it up as y equals 9 log base e of x, because ln is a log base e. And that should make your life a lot easier. And you can work from there, following the same steps that I did in the example. For 17, we end up with something very interesting, so I'm going to walk through that real quick. Now, I'm going to want to switch x and y first for 17, because we want the inverse. So I get x is equal to negative 7 log base y of 2. Now I want to isolate the log, so I'm going to divide off the negative 7, isolate the log, divide by negative 7 on both sides. Those cross out. I get that, I'll rewrite it the other way, log base y of 2 is equal to x over negative 7. Now I swoop to get these into the exponential form. Y is equal to, y raised to the x divided by negative 7 is equal to 2. Now this is interesting because the x and the y are right next to each other. So let me rewrite this. I want to have a little more space to take a look at this. Y raised to the x over negative 7 is equal to 2. I need y by itself. I need y equals in order for this to be a function. So how do I get rid of an exponent? In order to get rid of an exponent, I have to raise both sides to that exponent's reciprocal. So flip it. We did this in class like 3-4 lessons ago. Raise it to the reciprocal, and I must do the same thing on the other side. An exponent raised to an exponent like this becomes multiplication. So I get negative 7x over negative 7x, which is 1. They cross each other out. So I get y is equal to 2 raised to the negative 7 over x power. And that's actually the final answer for question number 17. I hope that none of the rest of them give you trouble, but you need to work through that. Difficult questions make you smarter. Okay, so struggle, embrace it, look over your notes, figure it out. You're intelligent, you got this. See you in class tomorrow.